the quantities which are independent of any other quantities are called as fundamental or the base quantities. Internationally accepted standard reference to measure anything is called as unit. The radian is represented by the symbol RAD and steradian is represented by the symbol SR. The distance of separation between them is very much greater than the distance of separation between two observatories. Hello everyone, welcome to session 1 of chapter 2, Units and Measurements. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. In this chapter, we are going to study about the basics, the fundamentals of the units and measurements and their importance in our daily life. And also, we are going to analyze the dimensions. We are going to learn how to write the dimensional formula and many more interesting concepts. So, let us start understanding this chapter by knowing some basic terminologies. The first one is physical quantity. So, let me tell you how important the units and measurements in our daily life. As soon as we get up in the morning, we go to some vegetable vendors, we go to shops, we'll ask for 1 liter of milk, 1 kilo of onions, 1 kilo of tomatoes. So for everything, we need some measurement. We have to ask them with certain units. 1 kg of onions, 1 liters of milk, 5 liters of water bottle. Like this, each and every day, we deal with units as well as measurements. So, we have to know about the units of those measurements, why the particular units are internationally accepted, why they are same all over the world, why they are called as System International the units. So, all these things are very important and also they are all related to our daily life as well. So, let us understand these things by knowing about some basic terms. So, first one is physical quantity. What is a physical quantity? If I ask you to measure something, you need a substance. So, physical quantity means the quantity which can be measured. The quantity which you are going to measure is called as physical quantity. The name itself says physical quantity, which means the substances or the quantity that is going to be measured is called as physical quantity. For example, we can measure mass, we can measure length, time, we can measure area, volume, velocity and etc. Anything that can be measured is called as physical quantity. As I told, we can measure mass, we can measure length, time can be measured and also area, volume, velocity, all these quantities can be measured and they are called as physical quantities. And then what are the classification of this physical quantity? What are the types? Let us go through this now. So physical quantity is classified into fundamental quantity and derived quantity. What is fundamental quantity? Fundamental means, the meaning of fundamental is the basic things or the base. So what are the fundamental quantities? Which quantities comes under these base quantities? Let us see. So the quantity which does not depends on any other physical quantity, they are called as fundamental quantities, which means the quantities which are independent of any other quantities are called as fundamental or the base quantities. The examples for fundamental quantities are the mass, the length and time. They are actually the base quantities which does not depend on any other physical quantity. There are 7 fundamental quantities and we are going to study about them in our upcoming slides. So the next type of physical quantity is the derived quantity. The name itself says derived quantity, which means the quantities which are derived from the fundamental quantities are called as derived quantities. Or we can also say as the quantity formed by combining or they are derived from the fundamental quantities, they are called as derived quantities. For example, area, volume, force, velocity. You will understand about this much better by knowing the fundamental units and derived units. So these are the example for derived quantities. They are combined or derived from the fundamental quantities. So the two types of physical quantities are fundamental and derived quantities. Fundamental quantities does not depend on any other physical quantity, where derived quantities are dependent on fundamental quantities. So next, let us understand what are units. What is this unit, or what is the meaning of unit? So the internationally accepted standard reference using which we measure the physical quantity is called as unit. I repeat, the internationally accepted standard reference, which means all the countries accepted this standard of reference to measure any physical quantity is called as unit. Because if you go to some other country apart from India, the unit will be called by the same name. If you go to some different country, it will be called as the same name because they are internationally accepted. Internationally accepted standard reference to measure anything is called as unit. There are two types of units, and they are fundamental units and derived units. What is the meaning of fundamental units? As I said, fundamental is nothing but the basic. Basic quantities or the fundamental quantities we have already discussed. They are mass, length, time and etc. So the units of those fundamental quantities are called as fundamental units, or they are also called as base units. Example, meter. So meter is the fundamental unit of the quantity length. Second is the fundamental unit of the quantity time. Kilogram is the fundamental unit of the quantity mass. So mass, time and length, these are all fundamental quantities or base quantities. So the units of fundamental quantities are called as fundamental units. Similarly, the units of derived quantities are called as derived units. For example, the derived quantities I have discussed already. Example, force, because they are formed by combining the fundamental quantities. The unit for force is Newton. So, example, Newton is one of the derived unit, and meter per second, speed of velocity, and joules, the unit of energy, and etc. So these are the units of derived quantities. So derived units are nothing but the units of derived quantities. So far we have learnt what is a fundamental quantity, what is a derived quantity. Physical quantity is divided into fundamental quantity and derived quantity. Similarly, unit is nothing but the internationally accepted standard of reference to measure a physical quantity. There are two types. One is the fundamental unit and the derived unit. Next, we have system of units. After knowing the meaning of unit, we have to know about system of units. System of units means the combination or the grouping of units. For the units of basic quantities, there are three systems that have been used. They are CGS system, FPS system and EMKS system. Here C stands for centimeter, G stands for gram and S stands for second. So as I told, the three fundamental quantities are length, mass and time. So in CGS unit, length is measured in centimeter, mass is measured in grams and time is measured in seconds. Similarly, we have FPS system and MKS system. MKS system is also called as metric system. Let us now discuss about this in detail, how the length and the mass, the time are measured in these three cases. Here is a list of system of units. First system we have is CGS system. As I said, here length is measured in terms of centimeter and hence the first letter C is considered, and mass is measured in terms of grams and the first letter is denoted by G here. Time is measured in terms of seconds and S stands for seconds. CGS means centimeter, grams and seconds, which means the length is measured in centimeter, mass is measured in gram and time is measured in second. Similarly, we have FPS system. What is this FPS system? F means the length. In FPS system, the length is measured in terms of foot and the mass is measured in terms of pound and time is measured in terms of seconds. Similarly, we have MKS system. M stands for meter, K stands for kilogram and S stands for seconds. Currently, we are using this MKS system of unit. Now, we use the SI system, that is the SI system of units, which is an enlarged and modified version of MKS system. Why it is called as the enlarged and the modified system? Because as the time passes, scientists came to know that each and every thing cannot be measured only with the help of this length, time and second. So they internationally accepted in the general conference and they have gradually added few certain things in SI system, and that is the extended or enlarged or modified version of MKS system. So the system of units which is internationally accepted at present is called as SI system, or it is the short form of the term System International the Units. System International the Units is shortly abbreviated as SI system. At present, we are using the SI system for the measurements. Now, we know what are the fundamental quantities and their units. So, the quantities which does not depend on any other physical quantity is the fundamental quantity. In SI system, we have 7 fundamental quantities. So, let us list out them now. So, what are those 7 fundamental quantities and their units? The first one is length. So, in MKS system, the length is measured in meter, as we all know. So, the SI unit of length is meter and it is represented by the letter M as its symbol. Next, we have mass. Mass is measured in terms of kilograms. The unit for measuring mass is kilogram and the symbol for this kilogram is kg. Remember, here K must be small letter. And next, we have time. This time is our next fundamental quantity. The unit for time is second and it is denoted by the letter S. Next, we have temperature. The next fundamental unit is temperature. The SI unit of temperature is Kelvin. It is denoted by the letter K. And remember, since the unit is named after a scientist, this K must be capital letter. Next, we have electric current. The SI unit of electric current is ampere and the symbol to represent this is capital A. Next, we have luminous intensity. Luminous intensity SI unit is candela and the symbol is CD. And also we have the last fundamental quantity, that is amount of substance, whose SI unit is mole, and symbolically it is represented as mole, MOL, mole. So these are the 7 basic or fundamental units. We do have a supplementary units along with 7 fundamental quantities. We have 2 supplementary quantities as well. So now let us see what are those supplementary quantities and their units. The 2 supplementary quantities are, one is the plane angle, the other one is the solid angle. And the unit for plane angle is radian. The unit for solid angle is steradian. So the radian is represented by the symbol RAD and steradian is represented by the symbol SR. So this is very important topic, examination point of view. The 2 supplementary quantities are plane angle and solid angle. 2 supplementary units are radian and steradian. So what is this plane angle? How it is defined? So let us now understand this. Plane angle is the ratio of the length of arc to the radius. So let us understand this by taking the example. I have a circle here. If I want to find the plane angle of this quantity, say for example this quantity, I'll consider this as radius and this is going to be my arc of the circle, or I'll call it as S, arc length. So plane angle is nothing but the angle between these 2 intersections, and plane angle theta is given by the ratio of arc length, I have called it as S, to its radius and I have taken it as R. So this is the definition of plane angle. Let us consider one more example. Here you have, this is the angle, we will call it as d theta. So d theta, and this is nothing but the arc length and I will call it as ds, and the radius is given by r. So in this condition, plane angle is given by d theta is equal to ds by r, where d theta is nothing but the plane angle and ds is nothing but the arc length and r is the radius. So here plane angle d theta is the ratio of the arc length to its radius. What is the SI unit of plane angle? It is radian. So let us now understand what is solid angle. So solid angle is denoted by d omega. It is the ratio of intercepted area of spherical surface to the square of its radius. The definition for solid angle is the ratio of intercepted area of spherical surface to its square of radius. So let us now understand solid angle with this example. Let us consider a watermelon. We have a surface of watermelon. Suppose if you cut this in a spherical shape and if you take that part out, you will find a cone-like structure, correct? And this is called as the surface area of interception, and this I will take it as radius. So in this example, let us consider this is the part which I have taken out. So this surface area, I'll call it as dA, and this part I'll call it as r, that is the radius, and here we have to find the solid angle, and that solid angle is called as d omega. So solid angle is defined as the ratio of intercepted area of spherical surface to the square of its radius. Since there is r, since it is square of radius, we have to represent it as r square. Do not forget, it is dA divided by r square, where dA is the intercepted area of spherical surface and r is the radius. Since the definition says the square of radius, we have to write r square. And the SI unit of solid angle is steradian, or it can be written as SR. So right from small quantities to large quantities, this physical measurements is expressed in terms of scientific notations by the power of 10. So this power of 10 and its prefixes, we have prefixes for different values. Let us learn about this one by one. So the factor 10 power 24, it is called by the name iota, and the symbol for iota is Y. So we have one more notation, that is 10 power 21, it is called as zeta, and that is denoted by the symbol Z. If the quantity is very huge, we cannot write the big numbers or very large numbers. So to avoid all such things, we can represent the quantities in these forms, in the power of 10. So we do have different names for the different values. So let us study about it in detail. 10 power 24 is called as iota, and the symbol used to denote iota is Y. Similarly, 10 power 21 is called as zeta, and the symbol which is used to represent zeta is Z. 10 power 18 is exa, the symbol is capital E, and 10 power 15 is peta, and P is the symbol for denoting peta. And 10 power 12 is tera, capital T is the symbol for denoting this tera value. 10 power 9 is giga. Remember, it is not small g, it is capital G that is used to represent giga. 10 power 6 is called as mega, and that is denoted by the capital M. 10 power 3 is kilo. We are all familiar with that, and it is denoted by K. That should be small k. Capital K is the symbol of the unit of temperature, that is Kelvin. So be careful. Small k is the symbol used to represent kilo. And 10 power 2 is called as hecto, and H is the symbol for that. Similarly, 10 power 1 is deca, and that is DA. So we'll call 10 years as a decade or a decade, correct? So 10 power 1 is nothing but 10, and the name for 10 power 1 is deca, that is symbolically represented as DA. So next we have the values for 10 powers and negative values as well. So 10 power minus 1. 10 power minus 1 can be written as 0.1. 10 power minus 2. It is 0.01. Correct? So the name for this 10 power minus 1 is deci, and symbolically it is represented as small d. 10 power minus 2 is centi, and C is the symbol of representation. 10 power minus 3 is milli, M is the symbol of representation, and that is small m. 10 power minus 6 is micro. We'll use mu, the symbol mu, to represent micro. 10 power minus 9 is nano. Nano is represented by the letter small n. And 10 power minus 12 is pico. P is used to represent pico symbolically. Next, 10 power minus 15 is femto, and F is the symbol used to represent femto. 10 power minus 18 is atto. A is the symbol that is used to represent atto. 10 power minus 21 is zepto. So Z is the symbol of zepto, and 10 power minus 24 is yocto. Y is the symbol of representation. So these are the prefixes or the powers of 10 which are used to measure the physical quantities in smaller and larger scales. So far we have discussed about the units and the types. So let us now study about measurement. What is this measurement? Measurement is nothing but the comparison of given physical quantity with an internationally accepted standard reference of same kind. Let us now study how to measure length, what is the range, and what are the different methods to measure the physical quantity, that is length. So usually a meter scale is used to measure the length, which ranges between 10 power minus 3 meter to 10 power 2 meter. And also a vernier calipers is used to measure the length of an accuracy of about 10 power minus 4 meter. In the screen you can see this instrument, and it is called as vernier calipers, which is having a main scale and a vernier scale in it. So in detail about this apparatus you are going to learn in your practical sessions. So a screw gauge and a spirometer can be used to measure the length as small as 10 power minus 5 meter. So you can observe this apparatus is called as screw gauge and this is called as spirometer. We are going to study about these things in detail in our practical sessions. So measurement of length using all these devices are called direct method of measurements, because we do have instruments and we do have the range to measure the length, and they are called as direct methods of measurements. So beyond this range, we cannot find the length, we cannot measure the length by using these instruments. And to measure the length for a faraway objects, for example, from Earth to other planet or from Earth to Moon, to find the distance or the length, we do use some special indirect methods, and the method which is used to measure the length of faraway object is called as parallax method. Let us know about parallax method. So measurement of larger distance. Parallax method is used to measure a large distances such as distance of planet or a star from the Earth. So what is this parallax? Why it is called so? The change in position of an object with respect to a point when it is viewed from left and right eye. We can understand this parallax by one simple example. Let us hold a pen in front of us. So close one of your eye and view the pen. You will find the position of the pen. Next, close the other eye and view the same pen. You observe that there is a relative shift in the position of this pen. So that relative shift with respect to the point of view when you view from right eye or the left eye, that relative shift is called as parallax. Or it can be understood like relative shift in the position of the object with respect to background. Parallax always refers to the relative shift of the object when it is viewed from two different positions. The distance between 2 points of observation is called as basis. In this pen example, basis is nothing but the distance between two eyes. So the distance between two different points of observation is called as basis, and the angle between two directions of observation of a point is called as parallax angle. Now, by using this parallax method, we can measure a distance of faraway objects. Say for example, the distance of a star or a planet from the surface of the earth. Let us now see how to measure the distance of a faraway planet by the parallax method. Now look at the diagram. Let S be my planet or a star which is at a faraway distance. Let D be the distance between the star and the earth. Let us consider A and B are the 2 points of observation from the surface of the earth. So A and B are my 2 points of observation. S, let us take it as a star, and D is the distance between star and the earth. And this theta is nothing but the parallax angle. Now, we understood this diagram. Let us understand how to measure the distance between the points of observation on the surface of the earth and the star. Yes, observe the planet from 2 different positions. We'll call it as observatories and we name them as A and B on the earth. They are separated by a distance B. You can see these are the 2 points of observations or the observatories. They are separated by a distance called B. And now in this example, this B is called as basis. Measure the angle between 2 directions, that is ASB is equal to theta, and that is called as parallax angle, or it can also be called as parallactic angle. Now look at the diagram. This is the distance of the star or the planet from the surface of earth. Since the distance is too far, the distance of separation between A and B, that is denoted by B, and this distance, when you compare with this distance, this is very small. When the distance between point of observation and the planet or the star is considered, the distance of separation between them is very much greater than the distance of separation between 2 observatories. Since it is very far, B by D value is always less than 1 and therefore theta is also very small. Hence, AB can be considered as the arc length B of the circle and it is having a center S and radius D. Imagine if this is going to be our circle as an extended version, this acts as a center and this becomes a radius. So, B is equal to d theta because we know in the study of plane angle, theta is equal to arc length divided by radius. Here, arc length is nothing but our basis, that is B. Because if you extend this as a circle, this part acts as a arc length. So now my arc length is B and the radius in this example is D. Hence, theta is equal to B by D, or we can write B is equal to d theta. And D is nothing but the distance of star from the surface of earth. So D can be calculated as B divided by theta. By knowing the value of B, that is the distance of separation between 2 points of observations, that is the value of basis, and the parallactic angle value, that is theta, we can measure the distance of faraway objects. We can apply the same condition to measure the diameter of moon surface. Let us now see what is the method to measure the size of the moon by parallax method. So look at the diagram carefully. This is the surface of earth where we stand and view with the help of telescope. We mark 2 views, that is the point A and B, that is nothing but the points on the moon, which is going to be a diameter. We can apply parallax method to determine the size or angular diameter of an astronomical object. Say for example, we have considered moon. Let D be the diameter of the moon. You can see here, this is the diameter of the moon. I'll call it as D. Let it be D. And when moon is observed from place E, this is the place of observation. When it is observed from the place E, let theta be the angle made by, here you can see theta, let theta be the angle made by 2 diametrically opposite ends A and B of the moon, which means these are the 2 diametrically opposite ends. Theta is the angle between 2 diametrically opposite ends of moon, and theta is called as parallax angle. If S is the distance of moon from the earth, S is the distance of moon from the earth, then theta, that is parallactic angle, theta is defined as what? arc length divided by radius. Correct? So in this example, if this is extended, this AB acts like a arc and this S acts like a radius. So here theta becomes AB divided by S, because in this example arc length is nothing but the diameter, and that is AB, which is given by D, and radius is nothing but S. So D by S. So the diameter of moon can be measured with the following expression: theta is equal to D by S we have, then D is equal to S theta. By knowing the value of the S and theta, we can easily measure the diameter of moon. These are some importance and significance of units and measurements. In our upcoming sessions, we are going to gain more knowledge about these measurements, dimensions, errors and its types, and many more interesting concepts. Until then, all of you please take care. Thank you.